assistant professor is G. Raju sir. I am here to explain about superposition theorem. Superposition theorem is nothing but it is a theorem which helps us to solve complex circuits, and it gives a simplified circuit that we can solve easily. So let's study about the superposition theorem. Introduction. What is superposition theorem? Superposition theorem states that in any linear active binetwork having more than one source, the response across any element is the sum of response obtained from each source considered separately, and all other sources are replaced by their internal resistance, which is nothing but in a linear circuits there are more than one source. The response in any element is calculated individually. That means while calculating the response from energy source, the another energy source are replaced to the internal resistance. The voltage source is replaced by short circuit, and the current source is replaced by open circuit. The superposition theorem is used to solve a network where two or more sources are present and used to and connected. In other words, it can be stated as if a number of voltage sources, current sources are acting in a linear network, the resulting current in any branch is the algebraic sum of all the current that will be produced in it when each source acts alone while the other independent sources are replaced by the internal resistance. It is only applicable into the circuit which is valid for the Ohm's law. So let's see the steps to be followed. Superposition steps. Turn off all the independent sources except one. Replace voltage sources with a short circuit and current sources with an open circuit. And analyze the circuit with the remaining other sources. Repeat the process for all sources and all responses and add all responses algebraically to get the total response. This means to simplify complex circuits, we need to follow certain steps, which includes first turn all independent sources, replace voltage sources by short circuit and current source by open circuit, and calculate individual response through each source and add algebraically all of them. Advantages of superposition theorem. There is a very good advantages of superposition theorem. First of all, it simplifies complex circuits. The theorem breaks down the complex circuits into smaller, more manageable parts, making it easier to analyze and design circuits. It calculates currents and voltages. The theorem allows engineers to calculate specific current or voltage without solving complex simultaneous equations. The theorem can be applied to any linear network, which is circuit that consists of resistors or impedance where Ohm's law is valid. Calculates currents and voltages independently. The theorem allows the voltages and currents created by each independent source to be calculated independently and then added algebraically. The main goal is here to calculate the current in any response in any element and add it algebraically. Applications of superposition theorem. It is widely used in power systems, communication circuits, control systems. The power communication circuits are more important in human life. Without communication, humans are no more. Control systems. Control systems are used in programming, like designing some electronic devices like that. Limitations. Superposition theorem is only used in linear components. It cannot be used in nonlinear components. And another limitation is time-consuming circuits with many sources. It means that if a circuit consists of more sources, more than two or more than three, it will be time-consuming for us to solve it. So it will be easier to solve easier to solve with two or three sources. That's it. Here's the problem on a superposition theorem. Let's solve this problem. Find the find the current flowing through 20 ohms using the superposition theorem. Here is the circuit diagram of the problem. Step 1. First, let us find the current flowing through a circuit by considering only the 20-volt voltage source. The current source can be open circuited, hence the modified circuit diagrams is showing the following here. So first we have to remove any one of the energy sources. So first, according to step 1, we have to consider only 20-volt voltage source. So the current source is replaced by a open circuit. Now here in step 2, we have to assume a voltage V1 at the node, and the nodal voltage V1 can be determined using the nodal analysis method. The nodal equation at node 1 is written as follows: V1 minus 20 by 5 plus V1 by 10 plus V1 by 10 plus 20 equal to 0. So we can simplify it: 6v1 minus 120 plus 3v1 plus v1 by 30 equal to 0. Here we can get v1 is equal to 12 volt. By this, by this the current flowing through the 20 ohm resistor can be found using the following equation. The equation is I1 is equal to v1 by 30. Substituting the value of v1 in the above equation, we can get I1 is equal to 0.4 ampere. Therefore, the current flowing through the 20 ohm resistor to due to 20 volt voltage source is zero point 0.4. We can so the current came here is zero point 0.4 ampere, that while we consider only 20 volts voltage source. Now step 3, let us find out the current flowing through the 20 ohms resistor considering only the 4 ampere current source. We eliminate the 20 voltage source by short circuiting it. The modifying circuit therefore given is as follows. Now we have to short circuit the voltage source, and the current source is back. In the above circuit, the resistors 5 ohms and 10 ohms are parallel to each other, and this parallel combination of resistors is in series with the 10 ohm resistor. Therefore, the equivalent resistance will be here. The equivalent resistance will be RAB, and that is equal to 5 into 10 by 5 plus 10 plus 10. That is equal to 40 by 3 ohms. Now, the simplified circuit is shown as follows. The current flowing through the 20 ohm resistors can be determined using the current division principle, that is I2 is equal to IS into R1 by R1 plus R2. By substituting the values, we can therefore the current flowing through a circuit when only 4 ampere current source is present is I2, and that I2 is equal to 1.6 ampere. Now, the step 4 is the summation. That means we have to add algebraically the both values by considering the individual response. The summation of currents I1 and I2 will give us the current flowing through a 20 ohm resistance. Mathematically, this is represented as follows: I is equal to I1 plus I2. So by substituting the values of I1 and I2 in the above equation, we can get I is equal to zero point 0.4 plus 1.6 is equal to 2 ampere. Therefore, the current flowing through the resistor is 2 ampere. So this is an example of superposition theorem. By the way, it is an easy problem. Conclusion. The superposition theorem is a fundamental principle in linear circuit analysis. It simplifies the analysis of circuits with multiple independent sources by allowing each source to be considered individually. This approach is particularly useful in understanding the contribution of each source to overall circuit behavior. While it is a powerful tool, its applicability is limited to linear time invariant circuits, and it cannot be used for circuits containing non-linear elements like diodes and transistors. Despite these limitations, the theorem remains an invaluable technique in electrical engineering for analyzing and decoding circuits efficiently. Here the conclusion says that the superposition theorem actually simplifies the complex circuits, but some limitations are there, but with that limitations also, it is an invaluable technique in electrical engineering for analyzing and designing circuits efficiently. And the matter which I collected here took reference from some books such as Engineering Circuit Analysis by William H. Hatt, Jack E. Cameli, and Stephen M. Durbin. The main aim as the main aim of this book is to provide a comprehensive explanation of circuit analysis, including the superposition theorem. And another book is Electric Circuits by James W. Nielsen and Susan A. Riddle. And third book is Introductory Circuit Analysis by Robert L. Goldstein, a beginner-friendly book covering the superposition theorem with worked examples.